Earth's twin formed from a collision about 4.5 billion years ago. Our moon likely formed when a Mars-sized object, known as Theia, collided with the young Earth. The impact was so powerful that it ejected a huge amount of debris into orbit around Earth. Over time, this material clumped together and eventually formed the moon. This theory, known as the giant impact hypothesis, explains why the moon is made up of rocks similar to Earth's outer layers. The moon is slowly leaving us. The moon moves approximately 1.5 inches, 3.8 centimeters, farther from Earth each year due to tidal interactions. Earth's gravitational pull creates tidal bulges on the moon, causing a transfer of energy that gradually propels the moon away. Over billions of years, this process will impact Earth's tides and lunar eclipses. In around 600 million years, the moon will be too far to completely cover the sun during an eclipse, ending total solar eclipses on Earth. Moonquakes happen. Just like Earth experiences earthquakes, the moon has moonquakes. These quakes are caused by tidal stresses from Earth's gravitational pull, and they occur deep below the moon's surface. However, unlike Earth, where water helps to absorb and dissipate energy, the moon's dry surface allows these quakes to last for up to an hour. Some moonquakes reach up to 5.5 on the Richter scale, which could potentially cause damage to lunar structures in the future. Moon dust smells like gunpowder. During the Apollo missions, astronauts found that moon dust, lunar regolith, has a unique smell resembling gunpowder when they return to the lunar module. This happens because the dust is made up of tiny, sharp particles that have been bombarded by solar wind for billions of years, creating a reactive surface. When the astronauts breathed it in, it released a metallic scent similar to that of gunpowder. The moon has its own time zones. With increasing interest in lunar exploration, scientists are considering establishing a lunar time system. Unlike Earth, time on the moon is affected by weaker gravity, and a day on the moon is 29.5 Earth days long. Time zones on the moon would help standardize communication and coordination between missions, especially as NASA and other agencies plan for long-term exploration. Day and night last 2 weeks each. A single day on the moon, from sunrise to sunrise, lasts about 29.5 Earth days. This means that both daytime and nighttime on the moon each last for around 2 weeks. The moon rotates on its axis at the same rate that it orbits Earth, a phenomenon called synchronous rotation, which means the same side of the moon always faces Earth. Moon's dark side isn't always dark. While the moon has a far side that never faces Earth, it's not always dark. The far side receives just as much sunlight as the side we see, except during certain phases. The moon's rotation is synchronized with its orbit around Earth, called tidal locking, so only one side is ever visible to us. But both sides experience day and night, just like Earth's surface. Moon rocks are priceless. Moon rocks brought back by the Apollo missions are scientifically priceless, worth billions due to their rarity and importance for understanding the solar system. Lunar rocks reveal secrets about the moon's formation, volcanic history, and early solar system conditions. Only a few countries, like the United States and the Soviet Union, have collected these rocks, and they are carefully stored for scientific research. Temperature extremes. The moon has no atmosphere to regulate temperature, so it experiences extreme highs and lows. During the lunar day, temperatures can reach up to 250 degrees Fahrenheit, 120 degrees Celsius, hot enough to boil water. At night, without sunlight, temperatures plummet to about minus 280 degrees Fahrenheit, minus 173 degrees Celsius, far below freezing. Future lunar missions will require advanced technology to protect equipment and astronauts from these temperature swings. There's water on the moon. In recent years, NASA and other space agencies have confirmed the presence of water ice on the moon. This ice is found in permanently shadowed craters at the poles, where temperatures are so cold that water remains frozen. This discovery opens the possibility of using lunar water for future exploration, providing essential resources for drinking water, oxygen production, and even rocket fuel. Let me know if you'd like any further details on specific points.